All right, homework for day number 3. Partial sums and errors. This is problem number 1, parts A and B. If I want to approximate the error for the first 12 terms of this, I can integrate and use the integral test from the 12th term on. So I'm going to do an overestimate. Of course, we know that the error of the first 12 terms will be less than the integral from the 12 to infinity of this thing. Alright, so let's do that. Okay, so if I'm going to integrate that, let me rewrite. Let's do 1/5 the integral from 12 to infinity of n to the negative 2 dn. What that would give me is negative 1/5 times 1 over n from 12 to infinity. Alright, so if we evaluate, we take the limit as b goes to infinity of negative 1 over 5b minus negative 1 over 5 times 12. So this, as b goes to infinity, goes to 0. And so we get, it looks like 1 over 60. All right, so the error there, an overestimate of the error would be 1 over 60. I'm guessing that I could do a relatively quick estimate on the underestimate, which would be the same thing from 11 to infinity, from 13 to infinity. I would just plug in a 13 there, and I think I'd get 1 over 65. So the error is somewhere between 1 over 65 and 1 over 60. There you have it. Okay, in part B, we're going to approximate how many terms are necessary to get this thing correct to 6 decimal places. 6 decimal places would be 6 zeros with a 5 at the end. All right, so I want to take the integral from some number k to infinity of n to the negative 4th dn, and I want it to be equal to 0.00000005. Okay, well, if I integrate that, I'm going to get negative n to the negative 3rd over 3 from k to infinity, which would be the limit as b goes to infinity of negative 1 over 3n cubed from k to b. Keep evaluating from here. Let's see what happens. I get negative 1 over 3b cubed. Clearly that's going to go to 0. Minus negative 1 over 3k cubed. Alright, so this will go to 0 as b goes to infinity. And we get positive 1 over 3k cubed. We want that to be equal to 0.00005. 0.0000005. So what does that mean? What is 0.00005? 0.05. That is the same as 1 over 2 times 10 to the 6th. 1 over 2 million. Okay, so that means I want these two to be equal. And I got a little bit of work to do. Okay, so I divide both sides by 3. Excuse me. Let's do this. Let's flip it over. Let's go 3k cubed equal to 2 million. Okay, divide by 3, so that's k cubed equals whatever 2 million divided by 3 is. Alright, now we take the cube root. So if I take the cube root, both sides, my calculator is telling me that k would be approximately 87.36. So I'm going to take that and go careful and go further. So I'd say 88 terms. 88 terms out in order to get that close to my actual sum. Alright, I want to address just part A here. So part A is interesting here. So I'm given that the nth partial sum of a series is given by this. So what that means is that the sum of just the first term alone, would be 1 minus 1 over 1 plus 1, okay, which is 0. So that means my first term is 0. Okay, the sum of my first two terms would be 2 minus 1 over 2 plus 1, which is 1/3. Okay, so that tells me that A2 is 1/3. Okay, now the sum of the first three terms would be 3 minus 1 over 3 plus 1, which is 2/4, which is 1/2. That is not A3. That's the sum of my first three terms. Therefore, I knew A sub 1 was 0. I know A sub 2 is 1/3. I know A sub 3 is blank. I don't know. But I know that the three of these added up. A1 plus A2 plus A3 equals 1/2. So this right here is 0. This right here is 1/3. And this right here we're going to find. So if I take 1/3 away from 1/2, that's like 2/6, and that's like 3/6. So it looks like A3 would be 1/6. Okay, so that's how you use this notation here. This is the sum of the first n terms. So if I want to find A sub n, all that I'm going to do is take S sub n plus 1 minus S sub n. Right, that's any summation minus the summation of the number of terms one short of that. Right, so if I took S sub 4 or S sub 7 minus S sub 6, right, I would get A sub 7. So actually what I'd like to do right now is I'm going to switch this and call this S of n minus S of n minus 1. Okay, so if I do that, hence like I do here, if I take S sub 7 minus S sub 6, I get this the seventh term. So if I take the sum of the first n terms minus the sum of the first n minus 1 terms, I'll get the nth term. So let's do that. So I plug directly in. Let's do this. So that would be n minus 1, which is just what we have, n plus 1. And I'm going to subtract the n minus 1th term. So that'd be n minus 1 minus 1 over n minus 1 plus 1. Well, if I simplify, nothing's changing here. But on the other side, I get n minus 2 over n. So I have to do some algebra. Okay, I would get a common denominator. I would multiply this by n plus 1 and n plus 1. And I'd multiply this over here by n and by n. And therefore my new red expression would be n squared minus n minus my new blue expression. I'm going to have to FOIL that out. It would be n squared minus n minus 2. And that would all be over the quantity n times n plus 1. So let's simplify and see what we get for a sub n. Right, all of this will equal a sub n. So n squared minus n squared, they're gone. Negative n minus a negative n, they're gone. Negative 2 minus a negative 2 would be a plus 2. So a sub n can be written in this way. Awesome. And you know what, while I'm at it, I'm just going to do part B. So write out the sum from n equals 1 to infinity in expanded form and find its sum. Okay, so the sum from n equals 1 to infinity of a sub n. Well, I don't want to trust and just put 1 in here and get 2 over, what would that be? 2 over 2, which is 1, because that's not true. All right, back here, I showed that my first term was 0. So that is a unique term in that way. Okay, so let's go ahead and from there see if we get the other terms that we had gotten before. So if I plug in a 2, I get 2 over 2 times 3, which is 1/3. All right, I had that before. So this is a sub 2. So a sub 1, a sub 2. I think a sub 3, we said we got 1/6. Let's see what we get. A sub 3, I would have 2 over 3 times 4. Yep, that's 2 over 12, which is 1/6. And so on to infinity. So our question is, what is this going to add up to? Well, the infinite sum, right, if I take s of n and I take the limit as n goes to infinity of that thing, should give me my infinite sum. So if I take the limit as n goes to infinity of n minus 1 over n plus 1, same rules apply to this as they do to, just your normal series, right, in your sigma notation. I take the highest power variables in the numerator denominator, divide their coefficients, and it looks like the infinite sum would be 1. All right, guys, that is a couple of homework problems there from partial sums and error for lesson 3. Peace.